Assume that there is a biconcave lens, with the first radii of curvature, R1, 32.5 cm, and the second radii of curvature, R2, 42.5 cm. If there is a distant object, what is the location of the image formed by violet light, and also, what is the location of the image formed by red light? Before we start, we have to know that different color has different wavelength. For the red light, it is about 700 nanometer and the violet light is about 400 nanometer. Since they have different wavelength, the index of refraction of these two color are not the same. It is 1.53 and 1.51 for violet and red light respectively in this question. Now, we can back to the question. For the distant object, we can assume the rays are effectively parallel. For the light ray below, since it has passed through the origin of the lens, we can assume it passed through straightly. For the upper light ray, we can assume that it is going towards the focal point of the biconcave lens, then it will diverge to the direction that is parallel to the x-axis. To find the location of image formed, we can extend the light ray backward until it has an interception with another light ray. Then, we can know that the image is formed here. For the distant object, the image must be formed at the focal point. Since the lens is diverging, therefore, the image is virtual and we can see that the one of the intercepted light ray is dotted line, which mean there is no actual light can go there. Therefore, the image is virtual. Then, to find out the location of the image form, we can use the lens maker's equation. The focal length of a lens in air can be calculated from it. The equation is showed below, where the f is the focal length of the lens. N is the refractive index of the lens material. R1 is the radius of curvature of the lens surface closer to the light source. R2 is the radius of curvature of the lens surface farther from the light source and D is the thickness of the lens. In this question, we can assume it is thin lens and the D is equal to 0. Therefore, if we circle out this part, and the D is changed to 0, this part will be 0. And the thin lens equation can be obtained, which is 1 over f, equal to, open blanket, n-1, close blanket, times, open blanket, 1 over r1 minus 1 over r2, close blanket. Finally, we can substitute the value of the unknowns into the thin lens equation. For the purple light ray, by thin lens equation, 1 over f is equal to open blanket, 1.53 minus 1, close blanket, times, open blanket, 1 over 32.5, minus, 1 over 42.5, close blanket. We have to notice that R1 should be negative in this case, since the center of curvature of the first surface is on the virtual image side. To make it easier, we can use this graph to explain. If the object is on left side, the image is supposed to be at the right side, therefore, the radius of curvature is positive if it is opposite to the object side. Oppositely, if the radius of curvature is same side as the object, the radius of curvature should be negative. Then we can continue our calculation by changing the R1 to negative 32.5. After the calculations, we can obtain the focal length is equal to negative 34.7 cm, and it is where the image formed by the purple light. For the red light, using the same method, and we can obtain 1 over f is equal to open blanket, 1.51 minus 1, close blanket, times, open blanket, 1 over negative 32.5, minus, 1 over negative 42.5, close blanket. Then we can know the focal length is negative 36.1, and the red image is formed there. The question is finished.